Right, next we're going to have a look at some functions questions. Here's a mixture of the sort of questions you can expect on this topic. Here's the first question. Let f of x equals root x minus 5. Find the inverse function and stick in x equals 2. And then part B, we'll come on to that one in a minute, that's a bit more difficult. The first one, we simply just say, well, f of x obviously is the function we've been given. Step number 1, we just write down basically f of x is y. Step number 2, swap around x and y, and then we square both sides. X squared equals y minus 5, and therefore if we rearrange it, we get the inverse function is x squared plus 5. Okay, and then next we say, well, obviously we want to find out the inverse function when x is 2. So therefore we just put 2 into this, and we get the inverse function is 2 squared plus 5, which is equal to 9. Okay, the second one's a bit more difficult. Here we go. So it says g is a function such that the inverse exists, and we're given that g of 30 is equal to 3. Find f of the inverse of g of 3. And remember, this was f of x here. This is quite a tricky question. First off, just note that what happens with an inverse is that the x and the y values are swapped around. So for example, if you had the point 2, 3, that would become the point 3, 2. Okay, the x and the y values in effect are swapped, they're reflected in the line y equals x. So that's the key bit of information that we have. So what does g of 30 equal 3 mean? Well, that means that the point, so when x is 30, the y coordinate is 3. Okay, that's the same thing. So the point 33 is on this graph of g of x. So if we have the inverse function, then the x and the y coordinates swap. So the x coordinate was 30, that becomes the y coordinate. The y coordinate is 3, that becomes the x coordinate. So that's basically saying that on the inverse function, the point 330 exists. Therefore, the inverse function of 3 is equal to 30. That means when we put the x value is 3 into the inverse function, we get 30. So that's what we need to be using. Okay, now we've got that information, the rest of the question is pretty straightforward. So f of g of the inverse when x is 3, we can basically just replace, well, the inverse of g of 3 we've already just worked out is 30. Therefore we can just say that now we're just doing f of 30. So we put 30 into our function of f of x, and therefore we get square root of 30 take away 5, and therefore we get 5. Okay, next question. Here we go, we're given a graph of f. It says write down the values of f of 2. So for this one, well, f of 2, well, therefore x is equal to 2. So if we go up and then go across, here's the point. So therefore y, in this case, y is equal to 3. Okay, easy. Says the next one, it says write down the value of the inverse function minus 1. Now method 1, which probably is the easiest to do, is to actually draw the line y equals x and then to reflect the point. We'll actually do that in part C anyway, so if you prefer this method, so it's probably easier. Method 2 is using the same idea as the previous question. We know that the y value of minus 1 becomes the x value of minus 1 for the inverse. Okay, so just think about that. So the y value of minus 1 would become the x value of minus 1. And therefore you think, well, the point 0, negative 1 would become the point negative 1, 0, because they swap over. So we find this point here. So this is the point 0, negative 1. And we know that this point here would become this point here for the inverse. So when x is negative 1 on the inverse, the y coordinate is 0. So therefore f of minus 1 of, so the inverse of f When we stick -1 in, gets 0. That may be a little bit complicated. Let's look at this next method, method 1. I'd probably prefer this method anyway. So method 1, which we do on part C anyway, is we basically reflect the graph. Now, the inverse of f, we just draw the line y equals x, and then we just have to reflect the points. Now, how do you reflect a point? You choose a point, you go, in this case here, if we want to go up to the line, and then we make a right angle turn, and there we go. So that point becomes this point here. I choose another point, go up to the line, make a right angle turn, it becomes this point here. Same as again, choose a point, go up to the line, make a right angle turn, and so on. So we get this shape here. And then it's pretty easy to work out what's happening. If I wanted to do this question, so the inverse of f and then sticking in -1, well, when is x -1? When x is -1 on the inverse function, the y value is 0. So we do get the same answer as this one here. Okay, next question. Here we go. So f of x is 3x minus 2, g of x is 5 over 3x. First one, find the inverse function. Very straightforward. There we go. Y equals 3x minus 2. Swap x and y. X equals 3y minus 2. Rearrange it. X plus 2 over 3 is y. Okay, very easy. Part B, again, pretty straightforward. We basically just replace, so we've worked out what the inverse function is. We put all that inverse function for f into g. So every time we see an x, we replace this x with what we've got here. So it becomes x plus 2 over 3. So there we go. We've got 5 on the top over 3 times x plus 2 over 3. That simplifies, 3's cancel, 5 over x plus 2. Okay, next one. Part C, I've actually altered the question slightly here to make it a little bit more difficult because we could get this sort of question. The original question restricted the domain, there we go, for x greater than 0, greater than or equal to 0. We'll do the whole graph. So, step number 1, find the y-intercept of the graph. Well, the y-intercept, is when x is equal to 0. So let's just stick x is 0 in here. And we're going to get h of 0 is 5 over 2. Let's just also check, I mean, they could ask us about this horizontal asymptote. It's basically told us that the horizontal asymptote is y equals 0. Well, why is that? Well, basically think about what happens, for the horizontal asymptote, think what happens when x approaches infinity. So as x gets really, really big, we're going to get 5 divided by a really big number. Obviously that's going to get closer and closer to 0. So therefore the horizontal asymptote will be y is 0. Then if we want to sketch the graph with the full domain, it's something looking like this. So here's our asymptote here for y is equal to 0. We're going to get a vertical asymptote at x is negative 2. Why are we going to get that? Well, because we can't divide by 0, and when x is negative 2, then this becomes 0. So therefore we're going to get the vertical asymptote x is negative 2, horizontal asymptote we have y equal to 0. We then mark the point where it crosses the y-axis, which is 5 over 2, and then possibly the best thing to do now is to stick in a couple of values and just see what happens. Basically, as x is very close to negative 2, for example, like negative 1.5, negative 1.9, something like that, and then see what kind of happens. We're going to get an ever bigger number because 5 divided by, it'll be a very small positive number on the bottom, and that's going to give us a very big answer. So we're going to get this kind of curve that goes off to infinity on this side, and then gradually goes down towards 0 here. And then we get the same thing here. We still have the asymptote going to 0 on this part here, but again, as we get very close to negative 2, for example, negative minus 2.1, see what happens, and we're going to get a very big negative number. Okay, so it's going to go all the way, or a very small negative number, if you want to think about it that way, it's going to kind of approach negative infinity. That's a little bit more difficult to understand, but I think it's worth just kind of considering this case as well. Okay, so that's part C and part D. Part E, for the graph of h of l, so here we go, so we'll use hx as the question defined now with just a domain x greater than or equal to 0. Write down the x-intercept. Well, first off, again, we just have to work out what the inverse function is. So this is my original function. I swap the x and the y. I rearrange it. There we go. This is my inverse function. Vertical asymptote. Well, the vertical asymptote, I can't divide by x equals 0. So therefore x equals 0 is my vertical asymptote. And then part G, it says that the inverse function is equal to 3. Well, my inverse function is y equals 5 over x minus 2. And so 3 equals 5 over a minus 2. Rearrange that. A is equal to 1. Okay, we've got two more questions. Here we go. X squared minus 3x plus k squared equal to 4. Two distinct real roots. Find the possible values of k. Step number 1, make it into a quadratic. So there we go. X squared minus 3x plus k squared minus 4 is equal to 0. Step number 2, label what a, b and c are. A is 1, b is minus 3, c is all of this, k squared minus 4, because none of that is in front of any x or x squared. Step number 3, what do we want? Two distinct real roots, therefore b squared minus 4ac is greater than 0. And then step number 4, put all these values in. So there we go, b squared, remember to put the brackets in, minus 3 all squared, take away 4 times 1 times k squared minus 4 must be greater than 0. Simplify it, and I'm going to get something that looks like this. It should end up with 25 greater than 4k squared. Okay, the final bit, I need to try and then solve this quadratic inequality. Okay, let's divide both sides by 4. 25 over 4 is going to be greater than k squared. At this point here, well, we know that it's going to be, if we square root this, it's going to be something to do with 5 over 2 and minus 5 over 2, but I need to work out which way the inequalities are going to go. Best way to do this, draw a little sketch. Here is k squared, and here is 5 over 2 and minus 5 over 2, just got from square rooting this. And then you think, well, what happens? This is saying that I want k squared to be less than 25 over 4, which is this line here. Well, when is k squared less than this? It's less than this for between those two values. So therefore, k is between 5 over 2 and minus 5 over 2. If you're not sure, you can always just stick in a number and see what happens. And let's check, for example, let's choose a value between those two. Let's choose k is 0. Is 0 squared less than 25 over 4? Yes. So it looks like we've got the inequality the correct way round. Okay, and then last question. This is actually a graphics calculator question, which makes it very straightforward. Part A, we can literally just put that on the graphics calculator, use our function, and this will be the minimum, so find the minimum function, and we get 2 minus 17. Okay, very easy. Part B, or part II, again, once we know that this point is the vertex, well, minus h, therefore h is 2, because it's kind of the opposite to what you'd expect, and then the k just is this minus 17 here. So there we go, f of x equals 2 bracket x minus 2 squared minus 17. Let's just see that we could do that using the completing the square method, because this could be a non-calculator. We'd write it down like this, because we know it's in this form to begin with. We'd look at this here, so we've got a minus 8. We divide it by 2, we get minus 4, but then we think we also have a 2 on the outside, so when we'd have a minus 2x and a minus 2x, that would give us minus 4x, and then we times it by 2 again, so therefore we only need a minus 2 in here in order to end up giving us minus 8x. Okay, so if you want to expand out this, you're going to get a minus 2x times by 4. There's the minus 8x. So that's step number 1. You then basically get rid of this number. So we've got a minus 2 squared times by 2. So let's get rid of all of that. We've still got the minus 9. And then if we simplify all of this, we get minus 17. And we can check that this works. If you expand out all of this, you should get back to this step here, which you do. Okay, but let's say we don't need to do this. It's a graphics calculator question, but in case it was a non-calculator question. Okay, and then it says solve the equation. Again, we could just use the graphics calculator, but again, we could be asked to do this without a calculator, so let's do it that way. So here's f of x. That's the function we've got. That's what we want. We want it to be equal to 0. Okay, just rearrange. So add 17, divide by 2, square root, and then plus 2. And I could leave it like that. Sometimes it's kind of nice to get rid of the square root on the bottom. So I could just do that times the top and the bottom by square root of 2, which is going to give me this here. And then if I use the laws of multiplying square roots, I can basically just say that root 2 root 17 is the same as root 34. So I could write it like that. Again, I don't really need to unless they specify, but they could do. Okay, so there we go. So a variety of questions all using functions.